Earth Systems 3209. Unit 4, the forces within Earth. References for this unit can be found in chapters 4, 15, 16, 19 in the textbook, and Appendix A and B in the curriculum guide. Unit 4, Topic 2.1. This topic will look at the evolution of plate tectonic theory by focusing on describing the evolution of the plate tectonic theory through contributions of various scientists. When we look at the earliest ideas of crustal movement, in the early to mid-1900s, geologists thought that ocean basins and continents were fixed, that they did not move. During the past 70 years, these ideas have brought about a scientific revolution in which new evidence and data support a slowly but continually moving planet. It was not until 1968 that a theory called plate tectonics provided reliable evidence supporting a mobile Earth. Information on this topic can be seen in the text in Chapter 19. When we look at the earlier ideas of plate tectonics, it is important to focus on several people that contributed to the theory of plate tectonics. Important people of the past and the contribution they made to support the moving Earth are seen below. One of the first scientists to make major contributions to a mobile Earth was a scientist named F.B. Taylor. In 1910, he published an article explaining the formation of the Himalayan mountains by moving continents. His ideas were not accepted because he failed to provide supporting evidence. He failed to provide evidence to support why the actual continents move. And a lot of the earlier scientists, this is the one thing that they lacked to explain, was why actual continents move. The second scientist that contributed to the ideas behind plate tectonics was Alfred Wegener. In 1915, Wegener rattled the scientific community again when he published articles concerning continental drift. So he added to Taylor's ideas. He suggested a supercontinent called Pangaea existed approximately 200 million years ago and since gradually split apart. When it split apart, it formed a north region called Laurasia and a southern region called Gondwanaland. Evidence of this existence of a supercontinent was given, but again, Wegener could not support his ideas. He could not provide a mechanism to explain why continents actually move. Wegener's best attempt at explaining why continents moved is he suggested that the continents move like icebreakers breaking through ice because of the pull of the moon's gravity and also because of the spinning of the Earth. A third scientist that contributed to the ideas behind plate tectonics and actually contributed to the ideas of Wegener and Taylor was Arthur Holmes. Arthur Holmes in the 1950s discovered the mechanism to explain why Earth's lithosphere can move. This was referred to as convection currents in the upper mantle called the asthenosphere. So the efforts put forth by Arthur Holmes helped suggest why continents move and directly supported the ideas proposed by Wegener's theory of continental drift. A fourth scientist that contributed to the ideas behind plate tectonics was a scientist named Alexander du Toit. In 1937, he mapped the fit of the continents. But not only did he map the continental coastlines that fit together, he went one step further and suggested that the continents will fit together more accurately by using the continental margins, and namely the continental shelves, instead of the continental coastlines. This is best seen by viewing Africa and South America. So du Toit's contributions to plate tectonics suggested that if the continents were once again put close together, that the coastlines will match. But if you look closer at the continental shelves which are underneath the oceans, and experience very little erosion, they will match even closer than the continental coastlines themselves. A fifth scientist that contributed to ideas behind plate tectonics was Harry Hess and Robert Dietz. Hess and Dietz in the 60s proposed that seafloor spreading hypothesis, and they suggested that the seafloor can be no older than 200 million years. Their ideas behind seafloor spreading explains that seafloor is created at mid-oceanic ridges and destroyed at oceanic trenches, and it takes approximately 200 million years for the seafloor to move from an oceanic ridge and down to be destroyed at oceanic trenches. So Hess's ideas of seafloor spreading contributed to the ideas behind a mobile Earth named the plate tectonic theory. A sixth piece of evidence suggested by two scientists, Frederick Vine and Drummond Matthews. Their work in the 1960s, these two scientists studied the ocean floor and found that magnetism in the rocks appear to change or reverse as you move away from one oceanic ridge. This idea was called magnetic reversals and is known to support the idea of seafloor spreading, which directly supports the idea of plate tectonics. The magnetism in the ocean floor is perhaps one of the most important pieces of evidence to support plate tectonics. And if we look at the diagram to the right, we will see that we have areas of high magnetism, north polarity, and areas of reverse polarity. These are shown as different colors. The white would represent normal polarity, and the pink would represent reverse polarity. And if you look at the diagram, you'll see that on both sides of the oceanic ridge, as you move away, the same pattern is seen on both sides of the ridge, which suggests that oceanic rocks were added to a mid-oceanic ridge in equal proportions as the plates moved apart. So Frederick Vine and Drummond Matthews' work with magnetism on the ocean floor provided overwhelming support of a mobile Earth, which supported the ideas behind plate tectonics. The seventh scientist, and a Canadian scientist, was J. Tuzo Wilson. Wilson was a Canadian geologist who proposed the existence of plates on the Earth's surface as a result of mapping the world's volcanoes and earthquakes. He put forth the idea that Earth consisted of several fragments called tectonic plates, instead of being made up of a rigid, solid layer that did not move. This idea revolutionized the way scientists think about the Earth today. He also proposed the existence of transform faults along plate boundaries, and that stationary hotspots in the mantle cause volcanism within plates instead of at the edges of plates. So Tuzo Wilson's ideas put forth the basis by which the plate tectonic theory was proposed. Other scientists, namely Xavier Lapéchon and Dan McKenzie, also contributed to the plate tectonic theory. McKenzie published the first paper on the principles of plate tectonics, and Lapéchon was the first to demonstrate on a computer the motion of the 6 major tectonic plates. He demonstrated that the total crust created at oceanic ridges equaled the amount of crust lost due to subduction and was destroyed at oceanic trenches. Therefore, the amount of crust being created and destroyed were equal amounts. Therefore, the Earth did not expand or contract in relative size because of the equal amount of lithosphere being created and destroyed. And this was computerized and demonstrated by Lapéchon. Let's look at some examples. Example number 1 reads, which Canadian scientist was responsible for the theory of plate tectonics? The Canadian scientists that put forth evidence and the basis for the theory of plate tectonics was John Tuzo Wilson. So the answer to this question would be D. Example number 2 reads, which scientists contribute to plate tectonic theory through their work on magnetic reversals? If we look at our choices, Hess proposed seafloor spreading, and the Toy mapped the continental coastlines. Mackenzie and Lepichon contributed to plate tectonics, but did not do much work in magnetic reversals. Wagner and Wilson were two of the main contributors to continental drift and plate tectonics, but the evidence that supported the plate tectonic theory through magnetic reversals was put forth by Frederick Vine and Drummond Matthews. So our answer to question 2 would be C, Vine and Matthews. Your turn. Take the time to complete the following question. The answer will follow on the following slide, so you can pause your recording now to prepare your answer. Question reads, which scientists contribute to plate tectonic theory through their work on seafloor spreading? So as previously stated, seafloor spreading was put forth by Harry Hess and was later supported by Robert Dietz. So Hess and Dietz were the two scientists that made major contributions to seafloor spreading in helping and explain the plate tectonic theory. So the answer to the question would be A, Hess and Dietz. Let's look at the summary. Scientists that made significant contributions to the plate tectonic theory in the past include Taylor, Alfred Wagner, who proposed the continental drift theory, Alexander de Toy mapped the continental coastlines, namely the continental margins, which fit better than the coastlines. Arthur Holmes, he proposed a mechanism to explain why actual tectonic plates move, and these were convection currents in the upper mantle, called the asthenosphere. Harry Hess and Robert Dietz proposed the idea behind seafloor spreading. Frederick Vine and Drummond Matthews studied magnetic reversals on the ocean floor. Tuzo Wilson proposed the basis by which we proposed the plate tectonic theory. And lastly, Lepichon and Mackenzie also contributed to plate tectonics, and Lepichon put forth the first computerized model demonstrating the movement of the 6 major tectonic plates, which showed creation of ocean floor at ridges and destruction at trenches occurring in equal amounts. So these 8 sets of scientists made major contributions to help propose and formulate the plate tectonic theory since the mid-1900s to present time.